Alright guys, we are back once again with another fun-filled, action-packed, flipped geometry classroom video. So, today we're going to be learning about similarity ratio, okay? So first off, we're going to start with similar polygons. And look at that, we've already got it all just written out there for you. So let's read it together. Similar polygons, what does that even mean? Polygons with the same shape but different size are similar polygons. So for example, look at this. Here's a similar, this is a similar polygon because they have the same shape. They're both triangles, but they're different sizes. So polygons are similar if corresponding angles are congruent and or if corresponding sides are proportional. And the ratio of corresponding sides is called the similarity ratio. So let's take a look at what that even means, though, because you know that you're like, what the heck does that even mean? Why is it? Whoa. Let's take a look at what that even means, though, because it might not mean anything to you yet. So look at this example, similarity ratio. Let me make it a little bigger so I have more writing space. Similarity ratio, order does matter. Take a look at the first question. What is the similarity ratio of triangle ABC to triangle DEF? So remember, the order does matter. So all you have to do here to find the similarity ratio is pick a side. I'm going to pick AB. AB is similar to which side? We're not going to say congruent because it's not congruent. It's similar. So which side is AB congruent to? It's congruent to side DE. Now let's take a look. AB is 8, right? DE is 12. You found it. Yeah, good job. So 8 to 12 is going to be my similarity ratio. Remember, you can do what to ratios? Ratios can be, if you said simplified, it's been a while, but give yourself a little solid high five. All right, 8 over 12 can be simplified to 2 over 3. So your similarity ratio would be 2 over 3. And you'll be able to see it, but if you pick any side, it's going to be the exact same similarity ratio. That's the special that's the special thing about it. Now, next, watch this. Watch how order does in fact matter. Take a look at this next one. What is the similarity ratio of DEF to ABC? You remember the first one, from ABC to DEF, we had AB to DE. This time we're going from DE. You can pick any side. I'm going to pick DE. DE is similar to side AB, but we're starting at DE. What's DE? It's 12. So 12 over, and what's AB? It's 8. So this time we can simplify once again, and it's going to be 3 over 2. Notice, I changed the order of the triangles. The order of my similarity ratio also changed. So order matters. Next up, we've got similarity statements. A valid similarity statement must match the corresponding angles and sides. Write a similarity statement for the triangles above. Remember, we had triangle ABC and triangle DEF. Remember, we had the congruent statements before. Remember, we had like triangle ABC is congruent to triangle DEF, like that. But these triangles are not congruent because the sides are different. The sizes are different. So this time we got to write a similarity statement, and it's almost the same, but not quite. You know, it's almost the same, but not quite. So remember, when it was the same, we had this sign, right? But we're not quite there. So what are we going to do? We're going to erase these first two. And wow, similarity statement, the symbol for similar is just one squiggle. It's just one squiggle. So if we want to write a similarity statement, what would we write? Triangle ABC is similar, one squiggle, to triangle DEF. And yes, the order does matter. So that would be my similarity statement. Alright, so time for some examples. Alright, look at number 1. We're going to list all the congruent angles and write a proportion that relates the corresponding sides. So let's look at number 1. So we see that there's triangle JKL is similar, not congruent, because the sizes are different, to triangle PMN. So we need to write which angles are the exact same. Remember, even though the size of the triangles is different, the angles can be the exact same. So this is going to be pretty straightforward. J right here is congruent to which side? P. So angle J is congruent to angle P. Now, what else is there? Angle K is congruent to angle M. And I'll let you figure the last one out for yourselves. But here's a little hint. I'm going to label these J. It's congruent to P. And then K is congruent to M. And then L. Alright, there you go. Okay, so, and then which sides are similar? We need to write using a proportion. So, check this out. JK right here is going to be similar to which side? JK is going to have a ratio with PM, so JK over PM. And this ratio is going to be the same as KL over which side? KL is going to be side MN. So it's going to be KL over MN. Then my last side is going to be LJ or JL, whatever you want to say. I'm going to say LJ over PM, or I guess NP in this case, NP. These ratios will all be the same between these two triangles. See? JK, PM, then KL, and MN, and JL, and NP. Boom. So those are the similar sides. So now I want you to do a similar thing on number 2. So on number 2, try that one. And you're going to have to, it might help you to draw two separate triangles instead of seeing them on top of each other. So try number 2. Alright, on to number 4. We are going to use similar figures to solve for the missing measure. So number 4, we got triangle ABC is similar to triangle DEF. We're trying to find the value of X. So we need to see the similarity ratio. So check this out. We can see that over here on this triangle, we've got EF. Let me make that a little clear. EF is 28. Now EF is similar to which side on triangle ABC? It's going to be similar to triangle on the side BC. So where's BC over here? That's 20. So we can see the numbers are 28 and 20. So EF, let's put that at 28 over 20. And that ratio is going to be exactly the same as we started on this triangle. So let's start on this triangle again. X over, and which side is DE similar to? Similar side AB. And what does the value of AB look on this other triangle? It's 25. So X over 25. These ratios need to be the exact same. So we're going to cross multiply to find X. We did this in class today. So 28 times 25 is going to be 700 equals 20 times X, which is just 20X. Then we're going to divide by 20 to get our X alone. So X equals 35. And there you have it. So now, you guys try number 5, knowing that the scale factor is 6 over 5. The scale factor is 6 over 5. And that's going to equal, using the other values you see there, try number 5. And last up, we're going to do the top question. Actually, you know what? I'm going to do the bottom one with you because someone in my class today is like, man, coach, I hate it when you do the easier problems. I want you to do the harder one. So, and this time, I'm actually going to do the harder one with you guys. So that way, you don't get as confused. So don't ever say that I never did anything for you. All right, so triangle JKL is similar to triangle MKN. But wait a second. Those triangles are stacked on top of each other. I can't even see them separately. Well, then let's draw two triangles to help us see it. We got triangle MKN. That's the smaller one. And look right here, MKN. So MKN. And then we've got the bigger triangle, which is going to be looking like this. Bam. JKL. And you see I got that from here, here, and here. So now what are the side lengths though? So KN right here, that'd be this side right here, that's 12. And what's MN, that's right here, that's X plus 1. Alright, now let's look at our bigger triangle. So on our bigger triangle, KL, well let's start with JL actually. JL is right here, and on our original picture we can see that it's 3X minus 2. And then what's KL though? KL is this whole length. So that's going to be 12 plus 20 because it's both of those lengths. So what's 12 plus 20? 32. Yeah, 32. Okay, so now we're going to write a similarity ratio to solve for our x. Okay, so look at our two similar triangles right here. All right, so let's see. We got Kn. Let's see, Kn is right here. Boom. And that's similar to which side? That's similar to side KL. So let's write that similarity ratio. 12 over, what's KL? It's 32. We can see our numbers are right here and right here. Okay, and that's going to equal to our Mn. And Mn's similar to which side? JL. And JL is 3x minus 2. So it's going to be x plus 1 over 3x minus 2. Now from here, we're just going to cross multiply to find our answer. So boom, bam, so that's 12 times 3x minus 2 equals 32 times x plus 1. So let's distribute, bam. So 12 times 3x is 36x. 12 times negative 2 is minus 24. Now that equals 32 times x is 32x. And 32 times positive 1 is plus 32. So we're going to subtract 32 from both sides, 32x I mean. That gives us 4x minus 24 equals 32. Let me bring this up over here. Well, somewhere over here. 4x minus 24 equals 32. Add 24 to both sides. That gives me 4. Oh my goodness. All right, add 24 to both sides. That gives me 4x equals 56. And then I'm going to divide by 4 to get my x alone. And x equals 14. Bam, there it is. We have solved for x. So guys, I did the hard one. I want you guys to try the easier one, the square and the above. And that's going to be the end of these notes. So I'll see you in the next one. Peace.